Okay, this is the scene west of San Antonio. Take two. I'm going to delete that last one so the latecomers don't have to listen to those low levels. So we're going to do it again, and you're going to hear a positive strike come down here to the east. There it was. And I don't know if that came through, but I was saying that we had the graduation in an outdoor stadium there, and people were seeing this light show off to the south, that storm right there, and it was quite a way to top off the evening there. So we've got a stormy pattern here, and yeah, voice level is good. That's great. My levels got bumped around, I guess, while I was gone. Hopefully that should be it for the road trips. I know I was kind of run down over the past week, and hopefully I'll get my energy back here. I got in about like 30 minutes ago. So let's head into the weather, and this is almost kind of like a forecaster coming on shift and looking at charts, and this is the way that we are going to do that. So see northerly flow in the panhandle. That's the first thing I see. And you notice that I'm starting with a surface chart, since that kind of shows me the ingredients and the kind of weather regime we're under. I can see we've got onshore flow. That's the other thing I'm looking at. I can see a lot of rain symbols all through here. So obviously something's going on in the low-level field. Wind field is kind of in disarray because of that. And that's because of a little bit of a meso-high back in that storm area. So we've got onshore flow feeding these storms, actually, and looks like about 10 knots there. And we see temperatures in the undisturbed air. We're showing upper 80s for high. Yeah, I guess those would be high temperatures there. And you notice the dew points, 76 and 74, very widespread through there. All right, so in between, we've got this relatively uncapped air mass, and we're going to look at the upper air charts, and I'll show you one little feature that we've got in today's mix, and we'll head to that. So this is the 250 millibar analysis from Canada there. Let me get that centered. And you'll see a little bit of a low pressure area. And when we have that anywhere in the U.S. during the summertime, there tends to be enough moisture and instability to kick off thunderstorms. So we keep an eye on these troughs during the summer months. So we've got that trough close to the Gulf moisture, which is out here. So we've got a pretty good pattern in place for thunderstorms, and you can see that on the radar there at Fort Hood, Central Texas right there. And another feature that you see right here in the middle, yeah, just towards the end there, you'll notice this boundary right here. You can see that pushing southward. So then we get new development along that boundary as that surges south. So probably during the evening hours, we may see a few showers popping up in the San Antonio area. And looks like there's one little shower there. And possibly in the Houston area too. Now, one problem is if you get too far away from the radar, then you start to lose that boundary. See, we're only detecting it at about maybe 4,000 feet, and then it goes south where the radar beam overshoots it. So your only solution is to go to some of the other radars like the TDWR up here and the Houston radar. Using that or a mosaic, you can kind of follow the boundary and kind of maybe trace that on your surface analysis there. Okay, so let's see. We've also got some storm action up in Wisconsin. I'm going to try to move up there and get that ready. Let's see. Green Bay is going to be too far east, I think. Milwaukee too far southeast. La Crosse, that might... I'm going to give that one a... Oh, I guess the action is in Green Bay. Okay, I'm going to switch over to that one. Okay, while that's coming in, let's check out the SPC analysis. don't know if you can hear it, just a little thunder. We've got an anvil over us, and I'll show you that right there. Yeah, that's a live shot. There's a little bit of lightning up in that cloud up in here. So back to our analysis here. We've got the storms kind of developing along that boundary that I showed you earlier just now, and then further back in the cool air, there's some other little boundaries here and there. So we're getting some of the Oklahoma development along this area of convergence here. So you see we have northeast flow in this area and southeast flow here, and that gives you enough convergence there to get some initiation. So we had that earlier. Okay, we'll move up to the northern plains and see what's going on. And I think that is going to be more frontal in nature, and it certainly looks like that on the charts here. So we've got low pressure up to the north here, so a little bit of troughing. And where's that front? I don't know. I think maybe just a first guess, I would say maybe a front back in here, and then it's kind of masked by outflow boundaries. So we're going to check out the thickness chart and see what we can find out. Certainly way up here in the Lake Superior area, there's some deep southeasterly flow feeding up into this low. So I'm not 100% sure that that's the cold front here. So I think we'll just go ahead and go over to that thickness chart. Let's see here. You notice the definite absence of any thermal gradient here in Texas. Maybe a very weak one back against the mountains. But the main boundary, way up here in Minnesota and the Dakotas, and looks like the warm front boundary is out over the Lake Michigan area right there. So in between, yeah, I guess maybe that would be a little area of outflow out ahead of the cold front. And then further back on the west coast, looks like we got a pretty strong cold front across Washington and Oregon right there. And of course, this time of year, that's going to be mostly moving up into Canada right there. Okay, so our radar, we're going to check out just Green Bay real quick. And we've got ourselves a squall line, an MCS, through that area there. One area of that squall line is kind of bowed out. The one good thing, though, is that the outflow, can definitely see that pushing out, so that kind of minimizes the tornado risk with that particular part of the line. Here I see maybe the outflow boundary maybe pulled into the storm a little bit. I certainly don't see anything in here, so these would have a slightly higher chance of tornadic development. Let me switch over to spectrum width, and I think that is probably the boundary right there. You notice we have low diversity air right here, and then we have more of the noisy, typical boundary layer stuff there. So I'm going to put a dot right about where that boundary is, and then I'll go back to base reflectivity. And yeah, it looks like that boundary a little closer to the storm. And you notice that we don't see the boundary on the base velocity. We have to use our other products, and we go over to spectrum width, and there it is. Storm relative velocity can sometimes uncover that, and indeed it looks like it does. So yeah, there you go. There's the position of that outflow boundary, and it's kind of drawn up a little tighter to the storm than what we have way out here. But so far, no supercellular structures at this time, and we take a quick look at the velocity products. Dominated mostly by inbound, so I'm going to fix that real quick. Kind of screen out some of those inbound motions and try to find any localized tight shear, and I don't see anything up and down that line. So it looks like wind, straight line wind, and maybe a little bit of hail is the main threat. All right, next up, let's see, what do we have here? We'll take a look at the 850 millibar chart and see our setup for moisture. And the number in the bottom left, that's going to be our dew point. Or is it the dew point? Let me check real quick because sometimes I'm wrong. So I'm looking way up in Canada. Yeah, there's a -6 right there. The way I do that is I look for negative values, and there's a -6 right there. That tells me it's not dew point depression, because depending on what site you go to, sometimes they interchange those, and that can really mess you up if you do that. So I always double check that when I go in and look at a chart. So we're definitely looking at dew point here, and we've got values close to the coast. Remember, this is up at 850 or 5,000 feet, close to 14 Celsius. That's going to be about upper 50s to 60 degrees Fahrenheit, so very rich air. And it looks like some of that's going up into the Midland area, up the Pecos River and up towards Amarillo. Not so much into Fort Worth and Oklahoma City. And this is this morning's chart, so just so you know. And then looking up north, we can check out the moisture. It looks like the main surge of that is going up in that southwesterly advection pattern ahead of the cold front right there. So that's feeding the storms that were earlier in Minnesota. Now they've moved out into Wisconsin. Then I'll look from above with GO 16. And it's going to flash like this while it's buffering. This is going to show the outflow boundary pretty well, and we can see that way back here. This is going to be right around the San Antonio area, and definitely see that boundary surging southward, and we can pretty much bet on more thunderstorm development as that moves southward. Diurnal heating, the loss of that later on may shut that down, but there's the other part of that boundary. You can see it right there. And then we've got that moisture feed coming on shore. And then it looks like as we go out towards Houston, we have some more convection. And I think that, I'm trying to think if that's the sea breeze. I think the sea breeze has probably already gone inland. That may be it right there. So anyway, showers here and there. And as you go up to the north, this is more overturned air. A lot less low cloud, and this is mostly just mid and upper level debris. Okay, let's see. What do we have next? We'll go to a sounding and look at Fort Worth. Definitely looks tropical. A little bit of dry air up at 900 to 850. And the reason we got these unusually strong storms, that lightning display last night, is the subtropical jet is in the area. So we've got 50 to 60 knot flow aloft, and I think probably even stronger there at Del Rio. Nope, they're down to 50 knots today. Corpus Christi, a little bit lighter. Looks like the subtropical jet is winding down a little bit, but still 40 to 50 knots up there is going to give you some well-ventilated storms. That helps remove the precipitation away from the developing updraft and helps preserve some of the severe structures there. So all these soundings we're looking at, this is Fort Worth, looks tropical, and Del Rio looks a little bit tropical here, a little bit of drier air aloft, but you can see the strong moisture right there. And we mix that with diurnal heating, throw in about upper 80s temperatures. That's going to give you parcels like that. You can see it's not very capped at all. So we got a little bit of cape in here. That's going to be about 500 to 1,000. It's enough for some decent strong storms. And hardly any capping. And I'll just take a look at Shreveport right there, and looks a lot like Dallas-Fort Worth there. So pretty good moisture down there at the base and not very well capped. So that means storms are going to go up early during the day, kind of like what you saw there on the opening graphics. Here's the dynamics. And the chart for right now is right there. Now this does show waves rotating through the flow. However, you notice that the winds there are only about 5 or 10 knots. So even though you do have waves there, there's a distinct lack of advection taking place here. So mid-level dynamic, or I should say deep layer dynamics, are not what's really triggering these storms. It's more or less this upper level low here, and that corresponds to a pool of colder temperatures in the mid and upper levels. Helps destabilize things, and you throw in the heating during the day, very strong heating. We're almost to the equinox, or I'm sorry, the solstice. Summer solstice coming up in 3 weeks, and also the moisture coming up from the Gulf. We've got a lot of ingredients, and all it takes is a little bit of that cool air aloft to really destabilize things. And the only thing we're missing for severe weather is stronger mid and upper level flow. So if we had that, that would help augment some of the dynamics, and we would see a response on the low levels, and we would increase the helicity. Everything kind of links together, and you would get this streamwise vorticity cranking up the helicity, and that's what would give you tornadoes. But fortunately, we don't have a very strong upper level flow in this part of the country. But chase season is not over, and the stronger flow aloft up there in Canada, and all we need is the next deep wave to move out onto the plains, and that will bring severe weather season back. So that's not going to shut down in the southern plains until about the 20th of June. All right, it's probably about time to look at the forecast. Before I do that, I'll give you this graphic, and I'll take a look at the chat here, see what is going on. I saw some messages come across from that Take One, and I missed those, and I apologize for that. I saw something about swamp there. We've got Ahmed here, and Kevin McKinney, Ryan, Sue M, Better Audio, Alexi and Kevin are here. Andrew saw a few pop-up storms really struggle there in Peoria, Illinois earlier today. 10 knots of shear from the surface all the way up to 300 millibars, so we'll do that. Audio is solid from Andrew. Michael Burrell says, good evening, Tim and everyone. Starting to become a scorcher of a time here in Atlanta. Yeah, I guess Atlanta is not very close to that upper level low there in Texas. So let me see if I can put that back up here. Might as well take a look at everybody's weather across the country. And yeah, more of a ridge across Arkansas and Louisiana there. And then Atlanta downstream from that ridge right there. Ryan's got some weather symbols, and Gulf of Mexico is fired up. Joshua has that severe thunderstorm warning in Wisconsin. Sarah reports 85 degrees there in northern Indiana. Humidity was up as well. Sue M says high was 89, humidity 35, which is low for there. Ancient Astronaut 89 there at Canyon Lake in Texas. Carl Berghoff checking in. Lots of lightning pictures last night. Very good. Juggalo for Life is here, really late again. Carl asks, did I receive the email? I'm still behind on email, and that's one thing I got to do tonight. I have not recovered from all this traveling. Okay. Jumping Flash, oh dear, is that why they say Hotlanta? Fun with Tech, I just clicked the like button. I appreciate that. John Booma is here. Juggalo for Life says, hey, John. And really hot today in the Chicago suburbs there. And you also notice Chicago underneath that north part of that ridge right there. So basically, wherever you have the ridge, you're going to have some hot, dry weather. And the other part of that ridge, over the northern plains right there. So we're in between here with the rain, and I kind of wonder if it's all the way back to Colorado there. Let's see if Colorado is getting anything. From the looks of this, I think they may be a little bit too far west. Yep, about as close as it comes is the Springfield area. So most of it, western Kansas and the Texas Panhandle. But quite a lot of shower activity there. Very typical early June pattern for this part of the country. All right, let's take a look at the forecast, and I think let's look at the short-term picture. And what I'm looking at, this is the high-resolution rapid refresh. This time of the year, the boundaries become really important, and I don't totally trust the model output of the boundaries. So what I look at on these charts, I'm looking at kind of a general picture of what's happening. So I can see it's kind of got that east-west thing in place. So everything looks good there. And the trend is basically for everything to shift southward through the San Antonio area. And this is telling me that that boundary is continuing to shift southward during the evening hours. And we can see by midnight it's already down to the Laredo area. And then I'm looking to see if anything regenerates in the East Texas area. So here again, we're looking at the general patterns, and it's going for some continuation out in southeast Texas. So the reason for that is probably going to be due to high theta E and probably some good storm relative inflow that could be augmented, supported a little bit by that thin area of strong upper level flow. So that could be increasing the storm inflow in this area right here. Got some very humid air right off the Gulf there, so that's probably is what's causing those. And this is at 12Z. This is around sunrise here. So definitely looks wet there for East Texas overnight. Okay, let's see. What do I have here? Yeah, here's the 850 millibar temperature and winds, and I figured I'd put this up because this is kind of tied to storm relative inflow. So there's the legend right there, and we'll run this up to sunrise. And remember, we were talking about it being rainy in East Texas, and you'll notice that we have 20 knot flow there at 850. So yeah, that's your storm relative inflow right there. Storms sitting out there in East Texas overnight and just soaking up the moisture like sponges. Okay, so hopefully your takeaway from this is how to forecast this when this happens in your area. So even though I'm kind of going in depth about East Texas, this is not really a regional forecast program. This is kind of me showing you how to use these techniques to forecast weather in your area when you see this happening there. So these are some of the charts you would look at for that kind of situation. And theta E, this is the other component. This is a quick look at your moisture, combined moisture and temperature. And this shows basically what this means is that given the same conditions in the upper levels from above the surface up to 200, 100 millibars, the higher this is, the more instability you're going to have. Again, given the same amount of upper air conditions, constant upper air conditions. So, very good moisture and temperature, very good potential for instability right there, feeding northward into southeast Texas. So, that's the other part of the picture there, theta E and wind there. Okay, so we'll head into the forecast, and because it's kind of a wet pattern, I'm going to look at the dew point here, and we're going to see what's going to happen over the next week. So let me get this fixed up here. So we're looking at the shading being the dew points. The purple is 70-degree dew points, and then the cyan is 60s. So by the time we do the forecast tomorrow, let's see, that's going to be on Sunday. We're going to have some of that moisture working its way northward. Looks like the leading edge of the cold front kind of stalling out right there. But then I see this other little sliver going all the way down to Texas. This is either an outflow boundary or it could be the front itself. It's kind of difficult to determine with this limited amount of data. But this is going to be a pretty potent convergence line, so I'm looking at probably more rain for tomorrow with that in the picture. Moisture intersecting that. Looks definitely rainy tomorrow. So we go forward into Monday. And I notice that we see some stout northeast flow picking up here. And I think that may be the actual cold air surging southward. Yeah, I would be inclined to think that this northern boundary is probably the front, because that's going to have a reflection in the moisture field. So let me go back to last night, or tomorrow night. See, I was looking at two lines, one there and one there, and this is what impacted the moisture field right there. You see the purple kind of go away with that coming through this area. I think that's got to be the front there. So that works southward and cuts in some of the moisture. So by Monday, looks like we're seeing that kind of working its way down into the Oklahoma and Texas area. And then the other outflow boundary all the way down to the Gulf Coast there. Okay, then for Tuesday, you can see that influx of cooler, drier air kind of eroding some of the moisture north of the Red River in Missouri and Kansas. And that pushes a lot of the boundaries offshore. So I think we're going to see the thunderstorms and showers come to a close around midweek there as that drier air filters in. And we've got this high pressure area coming in also. See, there's a high right there, and a big ridge coming down like that. And that's pushing the cold air southward. Kind of like a big density current coming south. And there it goes out in the Gulf. And ahead of that, looks like we got kind of a baroclinic system out there in the Gulf. See it right there? So I guess probably a little weather coming Ryan's way there. Probably precip chances going up in the southeast there for midweek. And going down for Texas. Then later in the week, we're up to Friday. We see the moisture return flow starting up. Looks like some upslope flow there in western Nebraska and western Dakotas right there. Maybe all the way up to Montana. And the dry line starting to set up in West Texas right there. So it looks like a little less of a tropical pattern and more of a late spring pattern. Okay, so this is next weekend, and I guess there's going to be chasing on the Central Plains, I think, around the 10th. So there's the 10th, and you see pretty good moisture there. Nebraska, North Kansas, and dry line through western Oklahoma. I think there's probably a frontal boundary right through here. There may be one in between in this area right here. Yeah, it's hard to tell. But in any case, this is a good potent area for upslope flow right there in the North Platte area. See that little backed wind area right there, southeast wind. 70s dew points coming into North Platte, so you would probably keep your eye on that for Saturday. Then we go into Sunday there, and we see a continued upslope flow pattern there for Nebraska. Dry line pushing out a little bit more towards the I-35 area. Depending on how strong the cap is, we could see development even further down the dry line too. And let's see, we get up to Monday. Looks like things shift northward. The moisture is getting kind of out of phase here with the pressure pattern, so I think the model may be starting to kind of lose its handle on this, but the general picture here, the moisture is shifting northward, boundary is also shifting northward, so this could be a South Dakota chase day, maybe moving into Minnesota there around the 13th and 14th. Very strong system there, 980 millibar low there over Manitoba. It's unusual. Where did that come from? Let me go back. Let me go back to... Yeah, it looks like that originates up there in northern Alberta and British Columbia. Pretty strong wave, I guess, probably moving around that ridge. So there it goes, Wednesday, 14th and the 15th. And that kicks a boundary back into the Central Plains, so looks like continued severe weather chances there in the Central Plains around mid-month. See, there's another strong front right there. You notice there's a lot of dry air mixed in here. The shading is not so strong in here. That increases the potential there for evaporative cooling, which can reinforce that boundary and push it even further south. So you see how that works. So that could drive more severe weather into the southern plains. Or I should say thunderstorms with the potential for severe weather around the 17th and 18th. And we're kind of model casting at this point. This is like 300 hours out, but that's your forecast there. So let's see here. I think we're about done with that. So I'm going to switch over to the outside camera. Not much to see there, just the backside of that convection there over central Texas. And I'll take a look at the chat here. 73 over 64 there in Summitville, Tennessee from Juggalo. Jumping Flash saw a mini bow echo come through the San Antonio area this morning. Mini bow echo. Yeah, I was in San Antonio this morning. That's where I came up from. I probably didn't pick up the computer and look at the radar or anything like that. I know there was activity last night, but that was mostly just... That was moving north, though. That was that lightning storm over the western parts of the city. But it was a pretty nice drive on the way back. I didn't hit any of this rain until I got to the College Station area. And you saw some of those pictures there. Juggalo got the notification for the live feed. I may not have it configured right. Sometime I may have to show you the settings and see if you all can figure it out. It may be due to the fact that I set all this up late. I set it up like at 7:45, and I think YouTube likes that stuff set up a little bit earlier. June 13th, interesting for the upper Midwest and Northern Plains from Carl. Ryan getting errors and resets. And Jumping Flash said it pushed through around 7 a.m. Yeah, I was asleep, so I missed that one. Okay, I think that's probably going to do it for me. I hope you enjoyed the webcast, and as I say, click the like button and subscribe and all that stuff, comment. And I'm going to get in there in a couple days and start looking at the comments, and tonight I'm going to try to get to the emails and get all that done because I've got a lot of work piled up here. Anyway, I appreciate you all watching the webcast, and we'll see you all tomorrow. Take care.